Hi, I'm Dr. Garrett here to explain to you the importance of proteomics. In the past 5 years, the number of proteomes sequenced has tripled from 30% to over 90%. No doubt a result of the new law Congress passed 5 years ago in 2025, requiring everyone to get their proteome sequenced by 2030. Now, for those of you that know what year it is, that means that anyone who does not have their proteome sequenced at this time is a criminal. For citizens who haven't quite caught up with the decade, proteomics is the study of all proteins in the body, millions of them in the human species. This information can be used to study diseases, help cure genetic malformations, and to determine the identity of someone based on the proteomic makeup of any of their cells. Some call this an invasion of privacy, but we all know what it would be like without proteomics. Now, you wouldn't want that to happen now, would you? That's why the government mandated that you get your proteome sequenced. Now, if you will remember, part of the law was you get your genome sequenced, your proteome sequenced, and submitted a universal ID. But also, you should be educated on what a proteome is. Here's my twin to explain what exactly a proteome is and how it works. Thank you, Austin. Sequencing a proteome really is quite easy, as there are a common number of themes or motifs between different proteins. In the past, it was very difficult to discover the structure of proteins due to the complex interactions between the amino acids. But today, since there have been massive advances in computer technology, the process has become easy. In 2018, the first proteome was sequenced. Today, sequencing a proteome is much faster, as it only takes seconds to discover a full proteome from a sequenced genome. Now, knowing someone's proteome for obvious reasons is very important. You can help fight various diseases, cure cancer, or perhaps target specific proteins in the body to help fight against enemies of the state. Here's a video to help explain the concept of proteomes more.
This started when I got introduced to this guy, Danny Hillis. I was like, I don't want to meet a guy from Disney. Danny didn't want to meet a doctor. And we got together, and what evolved from that was the ability to look with remarkable specificity and sensitivity of proteins in the body. If you have a metric of how to follow a disease, you're going to be able to develop therapies for the disease. Without a metric, your only metric is basically survival.
The moment something starts to change with the immune response, the proteins are what change first.
From a drop of blood, I can know how you're doing that moment in time. I can know if you have a fever, if you have an infection. So it's giving us a picture not just of the disease, but of the whole state of the body.
The idea of looking at proteins has been around for a long time.
People had a lot of trouble getting consistent results.
The off-the-shelf technology really wasn't optimized to do what we're doing now, which is look at the whole proteome. It was developed to look down deep and dirty at one protein at a time.
What applied proteomics did was treat this like a semiconductor line. We engineered an automatic process so that every time we do it, we get exactly the same result with the same input.
And that control allows us to collect data and think about data interactively, real time, dynamically.
What we can do now that's different is we can look at hundreds of thousands of markers at once.
It's incredible precision. Danny's proteomics can even tell the difference between what the weight of one neutron is in a specific protein. And you need visualization to be able to tell people what the distinction is between that range of proteins.
A lot of what applied proteomics is doing is solving that mathematical visualization problem of how do you see the pattern in those 100,000 numbers that tells you, should I give this person this drug, or how much of it should I give to them?
What is it about this data that looks to me like it's something I want to figure out? You know, these peaks look a little bit shifted, or those ones look a little bit higher than those over there. These are all working in concert together.
Once you figure out that pattern, you will be able to individualize medicine for every single person.
Instead of categorizing cancers by body part and lumps like multiple sclerosis, lumps like Alzheimer's, we can start to understand subsets in the spectrum of many diseases.
Proteins are going to be the key to understanding cancer ultimately, and I think to diagnosing it probably earlier than any other way that we can think of.
Proteomics offers the opportunity to really target some of the diseases that have been left behind. So if you put together a foundation that is targeting a disease, all of a sudden, you can start to get an understanding of the metrics of the disease and hopefully get answers in months, not years.
We need to start getting samples from healthy people, sick people, people who are being treated with different treatments,
Once we identify the markers for disease, it'll go on a high-throughput, low-cost platform so it can be scaled to thousands overnight.
It's actually going to be cost-effective to reward people for making the diagnostics, because they're going to save you tens of thousands of dollars of people getting the wrong medicine.
The future of discovery, the future of healthcare in the hospital, the future of healthcare in the doctor's office is going to be, I'm getting lots of information, but I have the appropriate tools to see it, to filter it, to put it together, to get the better relationships out of it and make the better decision.
To give to clinicians some view that they don't have otherwise of somebody's health. And they say, now I can measure something and now I know something that's going to make this person healthy.
Proteomics is definitely the next frontier. We're just beginning to see the patterns and make sense of them and use them to guide treatment.
The company was formed with the goal, really, of changing the world, which is the only reason we're here. We want to do things big, and we want to really make an important impact in how we care for patients.
As you can see, the importance of proteomics is monumental. Those who haven't sequenced their proteome are a danger to themselves and those around him. Now, here's a short video of somebody without their proteome being arrested. Get on the floor now! Get on the floor! Get on the floor! You didn't get your proteome sequence! You evil criminal! You can see how dangerous these criminals are. Look at him. He disgusts me. Thank you for watching this short documentary on proteomics.